with anything 7 through 14, okay, you're trying to solve for x. What do you notice about x, though? It's in two different places, right? So we have 4x and then we have 5xy. So we can't just move the 5x over and have, okay, what you can't do is we can't just basically take and be like, well, there's an x there, so I'm going to go, so don't write this down, xy, and then have 4x, and then divide by 4. It doesn't work that way. Okay? Why doesn't it work that way? Well, we still have an x here. It can be x equals all that, but that doesn't work because we still have an x in the other side. Okay? So is there a way for you to basically turn this addition problem into a multiplication problem? Yeah?
You can put the x outside of parentheses on the y.
Factor it, right?
Yeah.
So we can go x 4 plus 5y. We took a regular addition problem and turned it into, because all we did was just factor out the x. Okay. Now, the only thing we have over there, so like on 9, okay, well, we're not done here. So let's finish here. So what am I going to do to get x by itself? Divide by what?
X.
Nope. The 4 plus 5y, right? Goes away. Goes away. So what is x equal to? G over 4 plus 5y. All right, so on 19, you have that F is force, Q1 and Q2 as a vacuum is proportional to the product of charges, and then D is the distance between the two charges. We're solving for K. So if I have F equals K times Q sub 1 times Q sub 2 all over D squared. Okay, I could really just rewrite this as, because K is getting multiplied, this is the same thing as F equals K times Q sub 1 times Q sub 2 all over D squared. Okay? Anytime you multiply, that's the same thing as putting it on the top side of the fraction. Okay? So that's no different. So if I'm going to get K by itself, what do I need to get rid of first? Get rid of the D squared. So in doing that, I'm going to multiply both sides by D squared. So I have F D squared equals K times Q sub 1 times Q sub 2. Now again, I need to get K by itself. So what's my next step? What do I need to get rid of? Or what do I need to move over to the other side? The Q's, right? How am I going to do that? Divide both of them. So divide both sides by Q sub 1 and Q sub 2. Gone. Gone. So K is equal to force times the distance squared all over charge 1 in charge 2. Okay, so the goal is of 1.5 or foundations of 1.5 is to use a general and other problem-solving plans and strategies to solve real-life problems. Okay, so if what you want to do, and you don't have to do it exactly this way, but this is a good kind of idea in terms of what you need to do. Write it all down, include what you're trying to find, then model it, and then make sure you answer the question. You're not just solving for X or Q or Z or whatever variable you have. You have to make sure that you answer the question. So, and then check your answer to be sure that it makes sense. So, like if it says, you know, how fast were you going on Conister to go from Liberty High School to the middle school, and if it says that you went 1,232 miles per hour, that's probably not realistic, and we probably made a mistake somewhere. So be sure that it makes sense whenever you go about this. So it says a water-saving faucet has a flow rate of at most 9.6 cubic inches per second. To test whether your faucet meets this standard, you time how long it takes the faucet to fill a 470 cubic inch pot, obtaining a time of 35 seconds. Find your faucet's flow rate. Does it meet the standard for water conservation? We have a flow rate. We want to see if our flow rate of our faucet that we have meets the standard. Cubic inches per second, 9.6 at most, so it has to be 9.6 or less. So then, 470 cubic inch pot, 35 seconds. So what are we going to do with that information? If it's cubic inches per second, what do we need to do? How is this going to read, or what are we going to do with our two values? We have the 9.6, we're going to use that later. What are we going to do with the 470 and the 35? We're going to add, we're going to subtract, we're going to multiply, we're going to divide. Let them shake hands and meet each other for the first time. What? Divide. Right? So we're going to take, whoop, wrong one. I'm going to take the 470 cubic inches. Let's make it 470. And I'm going to divide that by the 35 seconds. What is 470 divided by 35? 13. Where are we at? So 13.4, excuse me, cubic inches per second. Is that a good thing or a bad thing? Bad, right? Because what does this number have to do? It has to be small. It has to be 9.6 or below. Okay? So for it to qualify, it doesn't qualify for the water conservation standard. So does it meet the standard? No. Got cut off kind of weird. You got plenty of room on the back. Here it says on a weekend trip you average 35 miles per hour in the city and 60 miles per hour on the highway. 150-mile-an-hour trip took you 3 hours. How much time were you driving in the city? So first off, you need to know what a particular formula, a common formula, that we're going to need here. That common formula is just your distance formula, which is distance equals rate times time. Know the distance in the city. Rate times time. Do we know a rate? 35. Do we know what time? Did we spend 3 hours in the...
I don't know.
No? Well, did we? Did we spend 3 hours in the city?
Doesn't say.
Okay, so do we know if we spent 3 hours in the city?
No.
No? So how do we know how much time we spent in the city?
We don't. It's X. I don't know. It's X.
Okay.
I don't think that's right.
Do we know about the distance on the highway? No? Do we know how fast we went? What's going to go here? If it was X amount of time in the city, how much time was spent on the highway? No, we're going to leave this in terms of X.
X.
Yeah.
3 minus X?
Bingo.
Equals 35 and then X is 60 and then
So if we do, I'm just going to kind of multiply here and just rewrite this so it'll be a little bit easier. And I'm going to have 180 minus 60x. Okay, I'm going to kind of do my math here, right? I'm just going to go ahead and distribute that 60 to everything inside. And then we're just going to call this 35x. So between the two, here and here, I'm going to add those up. What's the total distance that we spent, or we drove? 150. So since it was 150 total miles, I'm going to take these two and I'm going to add them up, and I'm going to have 35x plus 180 minus 60x. So I'm going to kind of work a little bit. I'm going to kind of kill two birds with one stone, and I'm going to have 30 equals negative 25x. Right? Okay. I just took 35 minus 60, and I moved that 180 over. So what's 30 divided by negative, or excuse me, it should be a negative 30, my fault. Divide by a negative 25. Where's what? All right. So what's x equal to? Okay. Since we're dealing with hours, we're not going to say 6/5 of an hour, right? So it's an hour and what? 20 minutes? Is it 20?
I'm not for sure. It's too
Too
early.
early. It's 10:36. Hour and 12 minutes, right? Because it's really 1.2 hours, right? So if we write this in terms of which is going to be the same as 1 hour and 12 minutes. Is that what we're looking for? Is that the question? Does the x belong to the distance in the city, or the time in the city, or does it belong to the time on the highway? Time in the city, right? Because here's your x right up here. Okay? Your x deals with the time in the city. So how much time do we spend in the city? Hour and 12 minutes. Now, what if it asked for how much time did you spend on the highway? Subtract it from 3 hours, right? And we'd say, well, an hour and 48 minutes.